In this video, we look at an example of a triple integral. Okay, and we focus on one particular aspect of triple integrals, and that is the evaluating step. Okay, that is one way to look at a triple integral problem. There is a second way to look at a triple integral problem, which is just the setup step. And what we can see in this problem, we'll take a look at number 8 here from the homework. But a triple integral has already been set up for you. Check. Okay, and it's our job to try to evaluate this triple integral. Okay, and just a quick note about triple integrals. This is the notation in general, the general notation. And this triple integral has a meaning, and it can have 6 meanings for a triple integral. One of the meanings is that you do an integral, and an integral of whatever function you've been given. Okay, so the example that we're seeing down here is that the function that we are being given in the problem is 1. Okay, and then one possible meaning is that you have to choose the order of integration. You do this as a dz, dy, dx. And if you've chosen z, that means that your function, your limits of integration can be functions of x and y. When you get to the y integral, the second of the 3 integrals, your limits of integration can be functions of x. And then your last integral is a dx integral, and you always have to have numbers on the very outermost integral. Okay. Now this is one of the interpretations. You can do one of the meanings is dz, dx, dy. Okay. And or as you can see on number 9, you can set this up as a dx, dy, dz, or a dz, dy, dz, dx, dy, dz. So you can, there are 6 different meanings for the integrals. dz, dy, dx is only one of the orderings. Okay, but that's more on the setup step. Let's get into the evaluation step and just evaluate the integral that we have been given, and then we will interpret our answer. Okay, so let's add a page below. And let's go ahead and do that integral that we were given. We were given a triple integral. The function we were being asked to integrate was equal to 1, and we were integrating dz, dx, dy. This was the ordering. Okay, and then we were told that z went from x squared plus 3y squared up to z is equal to 8 minus x squared minus y squared. Okay. And x, we were told, x is going from 0 up to some function of y. Turns out it's 3y in this case is what we've been given. And then y goes from 0 up to y is equal to the square root of 2. Okay. Now we treat this problem, evaluating triple integrals, is no different than it was for double integrals. We do this as a iterated integral. So the first integral, step 1, do the dz integral. Okay, which means that I do this integral with respect to z, so I need to find the antiderivative of 1 with respect to z, which is z. And then I'll evaluate from z is equal to x squared plus 3y squared up to z is equal to 8 minus x squared minus y squared. Which means that we get 8 minus x squared minus y squared minus x squared plus 3y squared, top minus bottom limit, and therefore we get 8 minus 2x squared plus 2y squared. Okay, Now that's the end of the first integral, and we have two of the integrals left. What is left? But we have the double integral, x going from 0 up to x is equal to 3y. Y goes from 0 up to the square root of 2. And then the inside function we have left is 2x squared plus 2y squared. So after doing the z integral, your answer has only x's and y's in it. So if you get something other than x's and y's, maybe something that has a z in it still, you need to reevaluate where you're going. So now let's continue on with the integral. We will look at our next iterated integral. Let's do the dx integral. So step 2 would be the dx integral. Okay. And just a reminder that this is section 15.5, and this is problem number 8. Okay, so let's do the dx integral, which means that we need to anti-differentiate with respect to x. There's the antiderivative with respect to x, and then we need to evaluate from x is equal to 0 up to x is equal to 3y. Okay, so we will get 24y minus 2/3. 3 cubed is 27, y cubed, plus x is equal to 3y, so I'll get 6y. Y times y squared is y cubed. And all the terms have x in it, so when you put in the bottom limit, you will get a 0. Okay. So where do we stand on this one? 27 divided by 3 is 9. 9 times 2 is 18 y cubed plus 6y cubed. And that simplifies the inside integral to 24y minus 12y cubed. Okay? So now we're on our last step, and that we need to integrate from y is equal to 0 to y is equal to square root of 2, 24y minus 12y cubed dy, which is now a Calc 1 integral, and we get, what is that, 12y squared minus 12 over 4 y to the 4th. And we're going to evaluate from y is equal to 0 to y is equal to square root of 2. Alright, so top limit, that's 12 times 2 minus 12 over 4 times 2 squared. And then they both have 0 in them, so when you evaluate the bottom limit, you get a 0. And so what do we get? 24 minus 12, which is 12. And I'm hoping the answer to this problem is, to this triple integral, is equal to 12. Okay? Let's double check our answer with the computer, and then we will talk about interpreting our answer. Okay, so I'll come over here to Mathematica, Palettes, Writing Assistant. Sorry, let's give it a moment here. Insert an integral. Go to the integrand of the first integral, insert another integral. Go to the integrand of the inside integral, insert another integral. And the function we're integrating is 1. And then we chose to do this as a dz, dx, dy problem. And we're integrating from x squared plus 3 times y squared to 8 minus x squared minus y squared. X went from 0 to 3 times y. Okay, and y goes from 0 up to square root of 2. Shift enter, and hopefully we get 12. Negative 6. Shoot. All right. Let's double check our limits. We're going from x squared plus 3y squared up to 8 minus x squared minus y squared. X goes from 0 to 3y, y goes from 0 to square root of 2. Okay. So, we have probably made some sort of algebra mistake in here. And let me pause the movie for a second and I can try to figure out where my mistake came in, and then I will then return to interpretation. So I found my mistake. It is right here at the beginning, unfortunately, that when I distributed the minus sign through, and we got negative x squared minus x squared is minus 2x squared, and I distributed the minus to 3y squared. I didn't distribute the minus, and I left it as a plus. So the correct form here should be minus 4y squared. But that will change your number all the way at the end. If you track through that minus 4, it will lead you to negative 6 as your answer. Okay, so that's something to work through, but the mistake is a pretty easy fix. Okay, the mistake is pretty easy to fix. The next thing we want to talk about is what did we just compute? Okay, and there are two ways to look at this. One is with maybe trying to sketch what is going on in this problem, and the other way to look at this is to get like a perfect sketch of what is going on. Okay, so we're just going to do a hand sketch of what we just computed. Hand sketch this problem. Okay, we were given that z went from x squared plus 3y squared up to z is equal to 8 minus x squared minus y squared. Okay. Which is, if you're looking for this triple integral, you're basically saying that x squared plus 3y squared is this parabola, and this is also a paraboloid, but the minus signs make it open downward. Okay, so we've got two paraboloids, one that opens up and one that opens down. Okay, and that when we're integrating from z, we're going from z equal to the bottom function up to z is equal to the, reverse that, but that we're integrating from there to there in the z. Okay, so we're looking at some region between these two paraboloids. Okay, what region between those two paraboloids? Which part of the region? Well, then you start looking at the other parts of the integral. Remember, we chose to do this as a dz dx dy problem. So the first z limits tell you your up and down part of the region. And the fact that there's a 1 here means that this triple integral is going to give us the volume of the region D, since we're integrating over D. So since there's a 1 there, 1 for your function, the integral is going to be a volume integral. Okay. Now, which part of the 3D region between these paraboloids are we looking at? The other parts of the limit said that x was going from 0 up to x was equal to 3y. And y was going from 0 up to y was equal to the square root of 2. Okay, that's another way of saying that x is equal to 3y is a line. Okay, it's some line. X is equal to 3y. And x goes from 0 across to that line, and y goes from 0 up to y is equal to the square root of 2. So the region that we're looking at in the xy plane is the part above this triangular region. Okay, and this is the hard part to draw, and what I would just kind of maybe draw a sketch for. We're looking at the volume between these two paraboloids, but above some sort of triangular region. Okay, which is this kind of hard region to draw between these paraboloids. Okay, so let's use the computer to sketch the answer here, and that we got that triple integral to come out to be a negative number. So that means that we have some sort of net negative volume. Okay. So let's take a look at the plot that we have going on here. We can look at a region plot 3D, and we're getting that z is bigger than x squared plus 3 times y squared. And z is less than the paraboloid that opens downward, and x has to be bigger than 0, but x also has to be, x bigger than 0, and x has to be less than 3 times y, and y has to be bigger than 0, and y has to be less than the square root of 2. And we want to plot that region for x goes from at least, x goes from 0. We can see in this picture that x has to go from at least 0 up to like 3 square root of 2. So let's say it goes up to somewhere around 4. No, that's 3. Let's say 6. Y has to go from 0 up to, we know the square root of 2, so let's make it a little bit bigger than square root of 2. Let's make it 2. And z has to be bigger than, well, we don't know. Let's go from, say, negative 10 to 10. We'll see what the plot says. So there is the region that we were, quote, trying to find the net volume of, okay? And let's see, if you do plot points, capital plot points, let's go to, say, 30. Should smooth this region out quite a bit. Okay, let's plot even some more points because we're hoping to see something that's trapped between, right? You can see a paraboloid on the bottom, something that's kind of curving from the bottom, and it's also curving from the top. And if you look at it from the top, it should look like a triangular region. Okay. And the fact that sometimes the function, that's curious. This function, where are the z values? Comma axes, label. Let's send this to, let's label the axes x, y, z. Huh. It's always looking like the function is a positive. Doesn't look like there's any negative values. So that triple integral should be the volume, and the z values always look positive, so I keep thinking that we should have a positive answer. So maybe we'll have to look back at our integral again. we got, the computer said we were supposed to get a -6, right? X squared plus 3 times y squared, 8 minus x squared minus y squared, dz dx dy. X goes from 0 up to 3y, and y goes from 0 to the square root of 2. Well, it looks like there's a little bit of a mystery left reconciling what the meaning of this answer is, but it is, this integral is of the form integrating 1 times dv, and therefore we should get a volume integral of the region in question. Here's the region in question, and it looks to be a positively volumed region, so we'll need to reevaluate the answer here. But so ends this video.